How's it going, ladies and gentlemen? Mr. Johnny here again, looking at 16.5. Here are the objectives, the stuff that you should be able to do after covering this topic. Dirt, how about this? That should say strong. Feel free to come back to this and check, see how you feel afterwards. But let's start with number one. Number one says nitric acid is a strong acid. This means that what? So the question's basically asking is what's it mean to be strong? A strong acid or a strong base? And I'll just jump the gun right now. It completely dissolves. So a strong acid or a strong base completely breaks up into its ions when dissolved in water. That's what makes it strong. All right. Uh, a weak acid would do something like this. It would be like, all right, cool. I have my H plus and I have my anion, and some of it is going to break up into H plus and A minus, but a lot more of it is going to stay as, the molecule together. All right, so strong acids, strong bases, completely ionized in water. Taking a look at number two. Of the following acids, blank is not a strong acid. So this is a low-level kind of question. You need to know which one of these things are strong, which one of them is not. Right? You just need to kind of know this one, commit it to memory. And HNO2 is not a strong acid. The rest of them are. Right? We got sulfuric acid, we have nitric acid, we got what's that? Perchloric acid. Anyway, it's a strong acid, and then we have hydrochloric acid. So all those are strong acids except for A. All right, so number three, we're looking to get into some math here. It says the Ka of hypochlorous acid, HClO, is this number. All right. What is the percent ionization of hypochlorous acid in a 0.015 molar aqueous solution of it at that temperature? So we got to remember, all right, well, Ka is just a special equilibrium constant of the H plus, the products for when it dissolves would be this all over the reactants, which would be the undissociated HClO. So that's the first thing we need to establish. So this is what the Ka expression is. All right, so the next thing that we're going to have to do is we're going to have to go, all right, well, if this is what I'm starting with, and this is my equilibrium, then how much stuff dissociated? I got to figure out, well, how much of it actually broke apart. Well, if I know Ka, I can do a little math, right? I can do like an icebox kind of problem. I started with 0.015 molar of that stuff, no H plus, no ClO minus. The change we're going to have to call X. So we used up a certain amount of HClO, and we made the same amount of H plus and ClO minus. So our end result would be our equilibrium amounts would be as such. So next thing that we're going to want to do is we're going to plug in these values into our Ka expression. So we get Ka equals X times X all over 0.015 minus X. And now we know everything except for X. So what we're going to want to do is we're going to want to solve it and rearrange this like a, what's those things called? Quadratic equation. Yeah. So we're going to combine like terms, get things, all on one side. We get 0 equals, what do we got here? X squared minus KEQ X. I'm sorry, that's plus KEQ X minus the KEQ times 0.015, which is just a number. So we get this as our quadratic equation. So we got to plug that into our quadratic equation of the whole x equals the negative b plus or minus the square root of b squared minus 4ac all over 2a thing. You're going to get two answers. Only one of them makes sense mathematically for this situation. So you plug that in, you solve for it, and you get x equals 2.12 times 10 to the minus 15. So that's how much of it dissolved, how much of it, not dissolved, but broke apart, ionized. So we're almost there. It wants the percent ionized. So this is going to be our part that ionized. So we got to take that 2.12 times 10 to the negative 5. I'm sorry if I said 15 earlier, I lied. It should just be negative 5. All over the whole thing, which was the 0.015 molar, and times it by 100. and you should get the answer, which I got to be 0.14%, which is choice D. All right, so again, first thing was, well, what's the Ka expression? All right, now I got to do my icebox to figure out what my equilibrium values are so that it can solve for the actual number using the quadratic equation. Right, once I got my x, that's how much of it dissociated, so I can use that in my percent formula and plug and chug, and that's it. All right, number 4. Of the acids in the table below, which is the strongest acid? All right, so we got Ka's here, and we know that Ka is the larger it is, the stronger it is. So we're looking for the biggest number here. Now what's going to throw you off a little bit is, first, you might be tempted just to look at those first numbers, but that's not what you should look at first. What you should look at first is it's times 10 to the what. So we're looking at those numbers. Which one's going to give us the biggest one? It's going to be the one that's the least negative. So we got 2 that are to the minus 4. So I know it can't be those options. It's going to be either CHO2 or HF. Now since you have the same scientific notation set up, now you can look at that first number. All right, well, which one's bigger? Well, HF. That one's bigger, so that one's going to be our strongest acid. All right, bring questions. See you in class.